All right, today's lesson is 5.6, properties of logarithm. Now, we need to recall some rules of exponents. Now, the product rule states that if you have some base raised to some power times the same base raised to another power, then you can just add up the powers. For example, if you have n to the 6 times n to the 3, since they both have a base of n, I'm going to keep it n, and 6 plus 3 is 9. Next, we have the quotient rule. Now, the quotient rule says if you have some base raised to a power divided by the same base raised to another power, you're going to keep the base the same, and then it's the top power subtract the bottom power. So we have n to the 6 over n squared. 6 minus 2 is going to be a 4. And then the last power rule that I want you to recall is the power rule. If you have a raised to the m raised to the m, you just multiply the n times the m. So we have n to the 6 to the third power. That's just 6 times 3, which is going to be an 18. Now, these are going to be the properties of logarithm. For positive numbers, b, m, and n, with b not equal to 1, it is true that now this is the product property of logs. If you have log base b of m times n, that is the same as saying log base b of m plus log base b of n. Now, the way I always remembered it is I like to multiply and I like to add. So if this is the product property of log, I'm now going to do the quotient property of log. And that states if you have log base b of m divided by n, then that is log base b of m subtract log base b of n. I don't like to divide and I don't like to subtract. And then the last property is the power property of logs. And if you have log base b of m raised to the n, that n will go out in the front. Those are our three properties. To expand, a logarithmic expression means to separate the factors inside the log into separate terms. And one thing I forgot to mention is these are the properties of log. They're also properties of natural log. So I could say the natural log of m times n is equal to the natural log of m plus natural log of n. Natural log is the one with the ln. So this is to expand a logarithmic equation expression. Now this is to write as a single log. I'm going to emphasize single log because that means you can only have the logarithm written one time. Basically means to condense is the opposite. So one is it to expand and the other one is to make it smaller. This is important when solving logarithmic equations. For our first example, we need to expand each expression using the properties of logarithm. So we're going to have log base 5 of a squared times b to the 7th. I'm going to first separate the a squared and the b to the 7th. And because that's multiplication, multiplication is going to be the product property. So I'm going to separate it with an add sign. So this is going to be log base 5 of a squared plus log base 5 of b to the 7th. So this is an addition. And from here to here, I did the product property of logs. I'm not done though. I now have this one right here. I have exponents. The exponent is going to go in front of the logarithm, and that's going to be the power property of log. So right here, this 2 is going to go in the front. So this is going to be 2 log 5 of a plus, now this 7 is going to go in front of this logarithm. That's 7 log 5 of b. So the 2 goes out in the front. The 7 goes out in the front. So from here to here, I applied the power property of logs. Let's go on to B. Now remember what I said, the logarithm is the same as the natural logarithm properties. So these are going to be the same properties. So this one right here is a division. I don't like to divide and I don't like to subtract. So the division is going to go with subtraction. So it's going to be natural log of 25 minus natural log of 3. So from here to here, I use the quotient property of logs. This can actually be simplified a little bit more because right here, the 25, that's actually a 5 square. So what I'm going to do is I'm going to rewrite the 25. So rewrite 25 as 5 square. I'm going to do that right there. So this is going to be a natural log of 5 square minus natural log of 3. And then I can move this 2 because it's an exponent in front of the natural logarithm. That is going to be the power properties of logs. So then my final answer will be a 2 natural log of 5 minus natural log of 3. Example C. Although I don't know if you really see this right here, the 7 and the a squared, those are being multiplied. This is the same as saying log base 3 of 7 times a, because a squared means a times a. And then how do I separate the multiplication? I separate it with an addition. That is going to be the product property. So I'm going to say log 3 of 7 plus log 3 of a plus log 3 of a. And because I have two of these, this is going to be a 2 log 3 of a. Now that's one way to do it. Or another way to do it, if you have a log 3 of 7a squared, I can separate this by a log 3 of 7 plus a log 3 of a squared. And if you have an exponent, it's going to go out to the front. So then this is going to be log 3 of 7 plus 2 log 3 of a. So I still got the same answer, just came about it two different ways. On D, division goes with subtraction. So now here I didn't put a base, so it's an automatic base 10, you just don't see it, but I don't even need to write it down. I'm going to separate the 6 and the x to the 1/3, and that's going to be a log 6 subtract log x to the 1/3. I'm not done. I see an exponent, so that's going to be the power property. The 1/3 is going to go in front of this logarithm. So I'm still going to have the log 6 in the front minus, and that's going to be a 1/3 log x. I have a multiplication here, and I have a division and a multiplication. First, I'm going to separate the division, okay? So this is going to be a natural log of 5x subtract natural log of 3y. Now, when you are separating right here, this one's fine. This is going to be a natural log of 5 plus a natural log of x. That goes together. Subtract, and then these two go together. This is going to be a natural log of 3 plus natural log of y. The reason why I'm putting the brackets is because when I distribute, this is going to be a negative natural log of 3, and this is actually a negative natural log of y. Because basically, these two are denominators. And in order for it to be a denominator, it needs to be a subtraction of the logarithm. So if you made a mistake, it might be right here. You might have put positive. That's why I put these in brackets to emphasize that this negative applies to all of this. So here, these are expanding. We took a single logarithm and we expanded it. For example, 2, we are now going to write it as a single logarithm. Write the expression as a single logarithm using the properties of log. always do your exponents first. So this 2 is an exponent, but of that logarithm, so it's going to go on the 7. So this is going to be a natural log of 7 squared plus natural log of z. Well, 7 squared equals 49. So this is natural log of 49 plus natural log of z. You are writing as a single logarithm, so you can only have the word log one time. And then here, addition is multiplication. That's the product property. So this is a 49z. And I put it in parentheses just so that you clearly can see that the natural logarithm is of this 49z. On B, I'm going to do all my exponents first. So this 4 is an exponent. This 3 is an exponent. And then this one doesn't have an exponent. Make sure you have the same logarithm base. So this is log 4 m to the 4th power plus log 4 n to the 3rd power minus log 4p. I'm going to first combine these two. Addition means multiplication. So this means log 4 m to the 4 times n to the 3rd. And now this subtraction means division. Now this p is going to be the only denominator. And remember, you are writing as a single logarithm. So I only write the word log once. The numerator is going to be an m to the 4th n cubed. The denominator is going to be p. Do not write logarithm 4 on the numerator and then logarithm 4 on the denominator. Do not do that. Remember, you're writing as a single logarithm, so you can only have the word log one time. Go ahead and try C and D on your own. Press pause if you need to on the video, and then press play when you want to check your answer to make sure you guys got it right. So first I'm going to go ahead and I'm going to do my exponents. So this 3 is an exponent and this 2 is an exponent. So this is going to be a natural log of 2 to the 3rd power minus natural log of 5 squared. Well, 2 to the 3rd power equals 8. And then 5 squared is 25. Right here on this property, subtraction is the quotient rule. So that means I'm going to divide. So this is natural log. Now 8 is first, so that's the numerator. 25 is the denominator. You're writing as a single logarithm, so you only want to write the ln one time. I'm going to do the exponents first. So this is going to be a log 10 squared plus, now here this is going to be a log 3x to the 3rd power. So that power of 3 applies to 3 and the x. Now 10 squared is going to be 100. And then here, 3 squared, 3 cube is 3 times 3 times 3, which is a 27. And then I have an x cube. And then addition means multiplication. So I'm going to go and I'm going to multiply these. So that's going to be log 100 times 27x cube. And 100 times 27x cube, that is going to be 27 with 2 zeros. 27 with 2 zeros, x cubed. Now, last part of the notes is going to be the change of base formula. For positive numbers, M, B, and A, with B not equal to 1 and A not equal to 1, if we have log base B of M, that is going to be a log base A of M divided by log base A of B. Typically, we do this because on the calculator, the base is always 10. So in order to make this with the same base, you would put log base b on the numerator and then log base b on the, log b on the denominator. And these bases right here would be tens. And then I could plug it straight into the calculator. But nowadays, the calculators have this type of form. Example 3, we're going to use the change of base formula to evaluate the expression. We're going to round only the final answer to 3 decimals. So here, what I'm going to do is I'm going to put log 2 on the top, log 7 on the bottom. Now that's automatically base 10 because I'm not writing it down. So now when I go to my calculator, I'm going to type in log 2 on the top. I'm going to close my parenthesis. Then I'm going to hit divide log 7. Now the reason why I'm closing my parentheses is to tell the calculator that that's the end of that logarithm. Uh-oh. And then we're going to go to 3 decimal places. So right there, 0.356. Approximately 0.356. Now you can plug straight natural log of 21 in the calculator. In other words, this is the same as saying log 21 over log of E. Now E has a power of 1, you just don't see it. So right here, I'm going to do log 21, close my parenthesis, divided by log E. So here's the second E, raised to the 1 power, close my parenthesis. And that is going to be a 3.045. Now watch, if I just type in natural log of 21, I'm going to get the same answer. Same answer. Last example. Use the change of base formula to solve the equation for x. Give an exact solution as a logarithm and an approximation. Solution to 3 decimal places. To start here, this is exponential form. I'm going to change it to logarithmic form. So I'm going to change to log form. In log form, this is log base 5 of 3 equals x. Now here, I'm going to go ahead and I'm going to do the change of base formula. So this is going to be a log 3 in the numerator, log 5 in the denominator. Log 3 divided by log 5. And that is 0.683. I'm just going to check my answer here. This is 5 raised to the 0.683. So I just need to make sure it equals 3. So let's see. 5 raised to 0.683. And that's pretty close to 3. That is 3.002, which is pretty close to 3. So let's go and let's change this to the logarithm form. So this is going to be log base 3 of 15 equals x. I'm going to do the change of base now. So this is log 15 divided by log 3. Log 15 divided by log of 3. And I get 2.465 because that 9 is going to make that round up. 2.465. And that concludes our notes.